History has been made today as NASA's Voyager 2 probe became the second man-made object to venture out into interstellar space. The announcement came 6 years after its twin spacecraft, Voyager 1, broke free from the protective bubble around the Sun, the heliopause. This is the region where the hot solar wind meets the cold, dense space between stars, known as the interstellar medium. Voyager 2 is now more than 11 billion miles from Earth, having passed this boundary on November 5. The news was revealed at a meeting of the American Geophysical Union in Washington. Comparing data from different instruments aboard the spacecraft, mission scientists believe the probe crossed the outer edge of the heliosphere on Wednesday last week. "This time is even better for us," said Nikki Fox, director of the Heliophysics Division at NASA, noting that one instrument, called the Plasma Science Experiment, is still functioning on Voyager 2. To have the Voyagers sending back information about the edge of the Sun's influence gives us an unprecedented glimpse of truly uncharted territory. The same instrument on Voyager 1, which crossed this boundary in 2012, stopped working in 1980. However, Voyager 2 still carries the instrument that will provide first-of-its-kind observations of the nature of this gateway into interstellar space. The two spacecraft, which look like a combination of a satellite dish and an old television set with rabbit ear antennas, were launched in 1977 on a mission to explore planets in our solar system. The twin probes have left the heliosphere, but have not yet left the solar system, and won't be leaving anytime soon, NASA said. The boundary of the solar system is considered to be beyond the outer edge of the Oort cloud. This is a collection of small objects that are still under the influence of the Sun's gravity. The width of the Oort cloud is not known precisely, but it is estimated to begin at about 1,000 astronomical units, AU, from the Sun and to extend to about 100,000 AU. 1 AU is the distance from the Sun to Earth. It will take about 300 years for Voyager 2 to reach the inner edge of the Oort cloud and possibly 30,000 years to fly beyond it. "We are looking forward to what we will be able to learn from having both probes outside the heliopause," said Suzanne Dodd, Voyager project manager at NASA's Jet Propulsion Laboratory in Pasadena, California. Voyager 2 is officially NASA's longest-running mission. The two spacecraft were designed to last 5 years and study Jupiter and Saturn. "Both spacecraft are very healthy, if you consider them senior citizens," said Suzanne Dodd, director for the Interplanetary Network Directorate, as the science results were unveiled at the American Geophysical Union annual meeting in the U.S. Capitol. Until recently, the space surrounding Voyager 2 was filled predominantly with plasma flowing out from our Sun. This outflow, called the solar wind, creates a bubble, the heliosphere, that envelopes the planets in our solar system. The PLS uses the electrical current of the plasma to detect the speed, density, temperature, pressure and flux of the solar wind. The PLS aboard Voyager 2 observed a steep decline in the speed of the solar wind particles on November 5. This is consistent with the conclusion that Voyager 2 has crossed the heliopause. Voyager's team members are eager to continue to study the data from these other onboard instruments to get a clearer picture of the environment through which Voyager 2 is traveling. A key concern is power, and NASA has to keep shutting down instruments to reserve power. But they may have 5 to 10 years left of life, she said. Each spacecraft carries a golden record of Earth sounds, pictures and messages, which aims to serve as evidence of Earth's civilization. NASA also is preparing an additional mission, the upcoming Interstellar Mapping and Acceleration Probe, due to launch in 2024, to capitalize on the Voyager's observations. "Voyager has a very special place for us in our heliophysics fleet," said Dr. Fox. "Our studies start at the Sun and extend out to everything the solar wind touches. To have the Voyagers sending back information about the edge of the Sun's influence gives us an unprecedented glimpse of truly uncharted territory. The Voyager probes are powered using heat from the decay of radioactive material, contained in a device called a radioisotope thermal generator,